All right, here we go for section 6.2, the law of cosines. So in previous sections we covered the law of sines. Law of cosines is presented to you on the board, and as we said in the last section, the law of cosines is used when you know all three sides of a triangle. It is also used when you know two sides and the included angle. So for those of you who want a picture for two sides and the included angle, that's two sides that I might know. That would be the included angle. That's SAS. So if you are given those three pieces of information, you are going to be able to figure out all six pieces of information from this triangle. So here you have, just like the law of sines, three ways to write the law of cosines. And all I'm going to tell you is it's remembered one of two ways. I don't think you need to know both. I think you should pick one, because essentially everything here on this left is equivalent to what's here on the right. They're just written different ways, and what I'll do is I'll just prove to you how similar these two are. They're the exact same formula, just written slightly differently. What I mean by that is if I take this formula right here, what I'm going to do is I'm going to subtract a squared to both sides. I'm going to subtract b squared to both sides. And what I'm left with is these would cancel. Negative a squared minus b squared plus c squared equals negative 2ab cosine c. And the way you come up with this formula here on the right is we are going to divide both sides by negative 2ab. And you will see that we arrive at well, the negative 2's, the a's, the b's, those all cancel. So the right-hand side is cosine c. And on the right, it is essentially, the only trick here is there's a lot of negatives, and they're going to essentially take this negative and divide it into all three. So what's happening here is two negatives make a positive, same thing here, and this becomes a negative here, leaving you with a squared plus b squared minus c squared all over 2ab. Keeping in note, these on the left here, all are side lengths, right? This is an uppercase C, that's an angle measure. So we talked about that last section, the importance between uppercase A and lowercase a, meaning angles and sides, depending if it's uppercase or lowercase. So let's look at an example. Here, what we have is we have a triangle. Clearly, they've presented to us SSS. And what I am going to stress when you are working on SSS, this piece is extremely important. Find the largest angle first every single time. All right? And what I mean by that is, we'll talk about why that is, but we talked as a way, which one of these angles, even though this is not drawn to scale at all, you can determine which is the largest angle, and it is angle B. And the reason I can say that is because it is opposite the longest side. So I know angle B is my largest angle. So I'm going to use my formula for cosine B. I know that cosine B is equal to a squared plus c squared minus b squared all over 2ac. And I'm really just plugging in. So it's cosine b equals, that's going to be a squared. So it's 8 squared plus 14 squared minus 19 squared all over 2 times 8 times 14. And this is just going to go into a calculator. Both these two sections are very calculator heavy, so I'm going to clear out of that, and what I've got is 8 squared. 8 squared plus 14 squared minus 19 squared. Now, I prefer to hit enter now, because if I do the division key, I would need to use parentheses, so do find a way that this works for you. And then I'm going to divide by, and I need to put parentheses here, 2 times 8 times 14, close the parentheses, and hit enter. Now that's great. What this is telling me is cosine B is equal to negative 0.450 9 if I round, but that's not your angle measure. To get your angle measure, you're going to have to use cosine inverse, right? So it would be the cosine inverse of negative 0.4509. What I would stress here is be exact. Don't even type in negative 0.509. Be exact and use the answer key. Cosine inverse of that comes out to, oh, I think I am in radian mode, so let's check here. Yep. That's going to be degrees. So if I had to convert that to degrees, which would be most familiar with, I would multiply by 180 over pi. So times 180 equals divided by pi equal, let's see, should I go like that? Divided by pi and hit enter. 116.8 degrees. So now we have a guaranteed answer for angle B is equal to 116.8 degrees. We can fill that in our chart. 116.8 degrees. Next we have to, we want to try to find it. Now at this point you can go in any order. A or C, it does not matter. Let's say we're going to look for A next. Switch colors when we look for A. For A, we'll use green, and we're going to use, again, a very similar formula. Cosine A is equal to, we're going to say B squared plus C squared minus A squared all over 2BC. And again, it's a lot of calculator work from here. I'm just going to be typing in 19 squared plus 14 squared minus 8 squared all over 2 times 8 times 4, 2 times 14 times 19. Right, so again, this all goes into a calculator. 19 squared plus 14 squared minus 8 squared. You hit enter, and we are going to divide by the entire total. 2 times 14 times 19, close the parentheses, press enter. And just like our last step, we are going to need cosine inverse to get this answer. So we have found angle A is equal to 22.1 degrees. If we round to the nearest 22.1 degrees. 22.1 degrees. And some would say you could use the law of cosines to find angle C, but I'm going to say that's overkill because the easy way to find angle C is just 180 degrees minus 116.8 minus 22.1, and you're going to hit enter. 41.1 degrees for angle C. All right. So now what I want to do is I actually want to take a second and I want to go back and I want to talk about, well, why did I say this at the beginning of this problem? Always find the measure of the largest angle first. So if you know all three sides, it's fair to say we can determine which one is the largest angle. It may or may not be obtuse. All right. So when you're using that cosine inverse here, this is that step when you're using the cosine inverse, right? When you use cosine inverse, you're either going to get an answer that is between 0 and 90, and you're going to know the largest angle is acute, or you're going to get an answer between 90 and 180, and you're going to know the largest angle is obtuse. Well, here's what's nice. Let's start with this option right here. Let's say that our largest angle is obtuse. Well, if you think about your ambiguous case, in an obtuse triangle, then there are no ambiguous cases. All right, there's always a triangle. Assuming that the three sides can make a triangle, there is guaranteed only one type of triangle. You never have to worry about obtuse triangles in the ambiguous. When you have an obtuse triangle, you never need to worry about the ambiguous case. What's happened? The ambiguous case comes in when you have angles that are acute. Well, if my biggest angle is acute, then my other angles also have to be acute, and therefore I can't have an obtuse triangle. And if I can't have an obtuse triangle to create, then I never need to worry about the ambiguous case. So that idea of always finding the largest angle first eliminates us from needing to think about the ambiguous case with cosine, which makes it, for some, easier to work on. Right? We can talk about this more in class if this is not making sense, but let's try to get one more problem in here to find the remaining angles and sides. And what I will caution you is the order here is extremely important. We must find this side first. There's not enough information, believe it or not, to find any of the angles as it reads right now. I couldn't use law of sines. So right now, I'm going to use and we switched it up a little bit. We could use the formula that states a squared is equal to b squared plus c squared minus 2bc cosine a. So then it's just a matter of plugging in. I don't know a, we'll leave it as a squared, and now it's really just going to be 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115 degrees. And this is all calculator work. Again, you're going to be typing in 15 squared plus 10 squared minus 2 times 10 times 15 times the cosine of 115, and that's going to be all one answer. Now, the side length is clearly not 451. The side length is done by taking the square root, because we have a squared is equal to the 451.78 and or 0.79 if you round correctly. What I will caution is when you take the square root, don't retype the number. Use the answer key. Get an exact or a more exact value. All right, we now know that angle A is equal to 21.3. I'm sorry, side A is equal to 21.3. Now that we have this information, we could use a variety of methods to come up with angles B and C. You could use law of sines. You could use law of cosines, but actually I think law of sines is a little easier. I would prefer to say sine of 115 over 21.3 is equal to the sine of B over 15. So here it's a cross multiplication. Again, I'm typing in 15 times the sine of 115. That's going to be the cross multiplication. That is this cross multiplication right here. And assuming you're getting better with law of sines, there's now just one more division that I need to take into account for, and it's going to be it's going to be a divide by 21.3. So let's bring that calculator back up. We divide by 21.3, and we've got this 0.63. We'll call it 0.64. Sine B is equal to 0.64. Again, you're going to solve this by doing sine inverse. So it's second sine inverse, and again, use the exact value. If you're not using the answer key, you're not going to be getting correct answers. 39.7 degrees will be our estimate for angle B. 39.7. 39.7. And the easiest way to come up with our answer for the final side, I know it's a triangle, 180 minus 115 minus 39.7. You're going to hit enter, and you can say that last side is 25.3 degrees. And just like you did with sine and cosine, I do think it's worthwhile to check here. Make sure that if this is your smallest side, it should be opposite your smallest angle, right? If here is your biggest angle, this should be your biggest side. If those aren't matching up, then you know you made a mistake somewhere, and you should go back and check your work. We have one small topic to cover one word problem and one small topic in a future video. I will see you then.